Welcome to today's webinar. The topic today is optimization with parameters in formulas. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the German and English webinars, technical content of the website, customer projects, and so on. I will be the moderator today, and I will answer your questions during the webinar. My colleague, Matthias Meyer, will be the presenter. He works in the product engineering team and also in the customer support team. I say something how you can ask questions, at least for the attendees who participate the first time. Switch off my webcam that you can see the full screen. Just press the button with the question mark, then enter your question in that field, press send, and I will receive your question and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's for the moment all from my side. I hand over to Matthias. Matthias, it's your turn.
Thank you, Andreas, and welcome to today's webinar. Today we want to deal with the optimization add-on, and first of all I want to show you how to activate the add-on and give you a small introduction, and after that I'm going to show you how you can use this add-on to optimize global parameters and how to use parameters in formulas and optimize them. So we are going in. First thing I want to do is optimize a continuous steel beam. It's going to look like this. We have two outer fields which have the same length and an inner field, and the outer fields differ, or the length of the outer fields differs from the center field. So we have a symmetric system. And what we also have is a continuous constant load of 10 kilonewtons per meters. We also want the weight activated, and we ask ourselves, okay, how long can this beam be at its maximum, which length it can span. The material is given, and also the cross-section is given. It's an IPE 240 and we have S235 steel. All right. So first of all, we have to activate our add-on. We're going to do this at the base data interface. So until recently, the add-on was here on the right side. Now it's on the left side. We activated checkbox. We also want to activate steel design. And we're going to choose the recommendations of the CEN. And click OK. And the first thing we have to do is define our knots. The first knot will be at 0, 0, 0. The second knot is at 5, 0, 0. We don't know what the maximal span length is. This is just a guess, and for start I'm guessing it's 5 meters. And so the next one is at 10 and the last one at 15. All right, then we have to put our beams between the knots like this. Then we have to add some supports. The first knot will be fixed in X direction. Okay. And the other knots are not fixed in X direction. Okay. Small check if everything is all right. It is. And then we apply some beam load. Oh, this was the wrong interface. We need this one of 10 kilonewton per meter. And like I said, the weight is activated. And now we don't want fixed length, we want them dynamic. So what we are going to do is we open the nodes table, and now we define some global parameters. I am going to delete them. Yes. All right. So where we are going to do this, we go on global parameters like this. And then we call the length of the order fields L outer. We can also make comments and to describe our parameters. Call this length of the outer fields. And then we have a length of the inner field. And give it like the same comment. And that's it for now. And now we have to make the coordinates of the nodes dynamic. So the first one is still fixed, but the second node should be dependent on the length of the outer fields. So we give it this parameter. We can also switch between parameter view and absolute view. And here the x coordinate of the second node have to be 1 time the outer load plus the inner length, not load, length for both. Okay. And the third node has to be here. 2 times the outer length plus 1 time inner length. Here, double click. All right. So now it's all on 0. Why? Because we have to define some values in here. Like I said, we can start with 5, but we actually want to optimize this parameter. So what we are going to do is we need a third formula for the whole length. So I call this L whole. And we define this as an optimization formula. So we define a formula, and the result of the formula we want to optimize. Yes. So the whole length is 2 times the outer length plus the inner length. And now it's, right now it's 15 meters. And then we press OK. So our beam is back. And now we open our optimization interface here at Calculate, optimization settings. And we want to maximize our whole length. So what we're going to do, we choose max global parameter. This is also new, also min global parameter. So yeah, these options are for minimizing or maximizing global parameters. Here we still have a problem because the parameters we need to change to optimize the whole length are not shown here. Why? Because we need to define them as optimization parameters. And for this, we also have to define a minimum and maximum value of this parameter. I'm going to start with 0.5 and put it up to 10. So here you can also kind of define the range of our parameter. If you say, okay, it shouldn't be longer than 10 or 11 or whatever, you can define this here. And we also need to define how many steps per optimization steps we want to consider. I'm going to choose 20 for this example. Press OK, and now if we go back in our optimization settings, we can see our parameters here. Right now we have 441 mutations, which is 21 times 21. So what is the program going to do is that it will start with 0.5 and then for both of one, and then start increasing one of the volumes. And when it has done this 20 times, it will increase the second value for one step, and also then using all the 20 other steps and so on. So this is like the most simple optimization procedure you can use. There are other possibilities, but for simplicity reasons, we want to stay with this optimizer right now. All right. Now we press OK. What we have to do first, which I forgot, is to press on activate. And when we have set this checkbox, we can also calculate this. Why is this checkbox here? It's for that you don't accidentally start optimization, because it will need a long time. So what I also want to do is only checking for ultimate limit state. So first we're going to steel design, deactivate the other states like this. And now I'm going to start the optimization process. And then you can see that it actually needs some time per step. So at one point I will cancel it, but I just want to show you how the calculation procedure is done. So like I said, it starts with 0.5, 0.5. It also will always adjust the model. And then now it's increasing one parameter step by step. But like I said, 441 optimization procedures will take a lot of time, so I'm going to cancel this right now. Okay, and if you cancel the optimization procedure, it will take the last optimum it could find and will set all our parameters to this last optimum. So it's set on 1.925 and 0.5, and use this also for our modular. Here I have the whole system optimized. You can see that our parameters are set to this optimization values, and I'm going to show you. Going to on steel design. Here you can see, yeah, the utilization is almost at 1.0. We could use more steps and then we would get closer to 1.0, but for now this is fine. And so our maximum length, we can use guide objects for this using dimensions. So in this case, the optimized length would be 23.8 meters. We can also see the biggest moment would occur here over the center supports, and also the outer fields are longer than the inner field. All right, so this was for the continuous beam. And the next thing I want to show you is how we could optimize a cantilever. So we want something like this. We have a cantilever with 3 sections, and for each sections we will use a different cross section. Here I choose these cross sections, and you can imagine that because we have a linear increase of the moment, so the biggest moment will occur here at the support. So we need the most resistance over here, and for this reason we could use a weaker cross section at the beginning on our beam, and so on. All right. So the first thing I have to do is activate our add-on again, also steel design, and yeah, I'm going to use the recommendations. All right, then I have to define my nodes, start at 0, 0, 0, and first segment will have a length of 3 meters, next one 6 meters, 9 meters. Okay, then I'm going to apply our beams. Start with the strongest cross section. Then the middle strong cross section and the weakest. Like this. Add a nodal force, okay, 5 kilonewtons, and then I also need a fixed support at the beginning of the beam, okay, like this. Also the self-load is activated, and now I'm going to define my global parameters. I name them length 1, length 2, and so on. And length 1 is the length of beam 1, and so on. Okay, I want to optimize them, so now I will change the type to optimization, and for the beginning we will stay with value, but I will change this after I applied these parameters to my nodes. So first node is at 3 meters, which is 1 time length 1, and so on. All right, and first thing we are going to do is we will conduct a steel design procedure 1 time, just to have an idea about how long our beams or our segments will be. And what we can see is, okay, the first segment could be a lot longer and the other ones are probably smaller. So what we are doing now is going back to global parameters. We want to optimize them, so we put them on optimization, and length 3, which is the length of this segment, we are going to start with length of 3 meters and give them a maximum of 6 meters. We'll use 5 steps. And the middle one, for the middle one, I'm going to start with 0.5 to 2. I kind of know the optimized length, so yeah, that's why I'm going to choose this. And for the last one, for length 1, we start with 2, and it's between 2 and 4. Yeah, like I said, I chose these values because I kind of know what the optimized length is. Okay, then after this, we are going to open our optimization settings, and now we only want to optimize length 3, because also length 3 is kind of independent of the other length. And so we have to choose parameter length 3, deactivate the other ones, because we only want to optimize this one right now. Press on active, and then we press OK and calculate. So we have 6 mutations now. You can also watch our optimization process over here. And it's basically doing nothing, right? It's not doing nothing. Let's check this again. Length 3, between 3 and 6. We choose particle swarm, but I want to use all mutations. So we activate this again. And let's see if it's going to do some optimization now. Yes, looks good. So we start with 3. We have an utilization of 0.6, now 0.8. And what we can do is, as soon we found our optimized length, we can cancel this to save some time. So probably the next one, for the next one, the design ratio would be too high? Yes, it is. So I'm going to cancel the calculation. All right. Okay. Now this one has a length of 4.2. You can check this by double-clicking on the beam. Yes, 4.2. And what I'm going to do now is I'm going to go back to optimization settings, and I want to save this value. So I'm going to change this to value. So other optimizations processes can't change this value. It's kind of fixed now. The length is fixed. Okay, I press here, and then I will continue with the length of beam 2. Choose the same settings, but yeah, go to length 2, activate it, press on active, and we're doing the same again. And now it already starts with 0.972. All right. Yeah, because why we are still here? Because it still has the optimization value or the utilization of the first beam. So, but now with 1.7, this middle beam is too long. So we are, yeah, the utilization is more than 1. So we can cancel this. And we are stuck with our optimized volume of 1.1. We are going to change this value, the definition type to value. Okay. And in order to have a better, we also have to go back to this because this no longer exists. And what we can also do is we say we only want to optimize beam 1 now. So this can save us some calculation time. And now we open the optimization settings again. We will optimize length 1. Now we have to activate, press on OK, calculate all. And now only beam 1 will be designed, which, yeah, like I said, will save us some calculation time. So we start with 2 meters, and then will be increased to 2.4. Maybe it will do one more. Yes, and probably the next one will lead to a failure. All right, so we cancel. Yes. Okay. Now we have our optimized cantilever. We can add some dimensions. All right. And here we have a length of 8.1. Now I only used 6 steps, which is actually not that much. If we have a look in our steel design, calculations and have a look on the utilization of all beams, we'll see that there's still room for longer beams. But in this example, I used 100 steps. And we can see, okay, the utilization is more or less 1.0. And we have a length of 8.3. All right, that was it from my side, and I will give back to Andreas.
Thank you, Matthias, for your presentation. At the end of the webinar, I have an additional hint for you to our online courses. There's the RFEM 6 course. That's a course for beginners. Then the Eurocode 2 course for the concrete design with RFEM 6. The Eurocode 3 course for the steel design. The Eurocode 5 course for the timber design. And the Eurocode 8 course for the earthquake design. Yeah, for more information, just scan the QR codes or click at the links here. You can get such a course for free when you submit your customer project and we publish the project. Just scan the QR code here or click at the link and you will reach a website where you can upload your files. Yeah, you can also write an email to info@dlubal.com to my hands, and I will answer you what files I need. It's not much work for you, I promise. Then a hint to our free online services, whereas, for example, the Dlubal community, you can ask questions there to our software. Then, our team or other users will answer you. You can determine snow, wind, and earthquake loads with the GeoZone tool. Then there's the cross-section property page. You can download 3D models, for example, as a template for your project. If you don't already use our programs, just download the trial version. For example, for RFEM 6 or RSTAP 9, or section or our wind, just scan the QR code here. And you can explore all our free services when you click at the link here or scan the QR code. You can get more information on our website, dlubal.com, for example, the recorded webinars, the knowledge base articles. You can ask questions to our AI assistant, Mia, 24/7, all the time. Okay, that should be also all from my side. I thank you for your attention. Thanks to Matthias again for the presentation. I hope we meet each other in a future webinar. See you. Bye-bye.